Today we're going to look at something that's technically review. We learned how to write a sine or cosine function from a graph. Today we're just putting that into context, so the graph will mean something in real life. First of all, let's review how we get all of those four pieces for our equation from a graph. For both sine and cosine functions, these steps will work. Notice this time that b is factored out. It makes it a lot easier to find that C value, that horizontal shift, if B is kind of taken out of the picture. The A value for both sine and cosine is our amplitude. It's how tall the graph is between the minimum and the maximum. So from the 0 to the maximum, or from the 0 to the minimum, gives us our amplitude. So if we find the maximum and the minimum heights on your graph, subtract them and divide by 2, we'll get our A value. B, the original equation we found for B was 2 pi over B gives us the period. But if we solve that equation for B, because we'll know the period from the graph, we need to work backwards to find our B value. We get B equals 2 pi divided by the period. C is our horizontal shift, and we just need to look at the graph, figure out, are we writing a sine function or a cosine function? That depends on, are we starting at the 0 or are we starting at the maximum? Is there a reflection? And we just need to put all of that together to find our C value. I'll walk you through that when we get to the graph. And finally, that D value, very similar to the A value, the D value is the vertical shift. And we can find if there's a vertical shift if we add the maximum and the minimum and divide by 2, or basically it's the average of our max and our min. So here we've got our essential question: how can we apply sine and cosine functions to solve problems? Taking a look at our first example, we have average monthly temperature over the course of a year for the city of Cape Town. Obviously, in most places, that average temperature goes up and down depending on, is it summer, is it fall, is it winter, and then the temperature will start to rise again from spring back to summer. So we get this sine or cosine wave to our temperature throughout the year. We've already got our graph plotted for us, so let's just find those four pieces of information we need. We need to decide, are we writing a sine function or a cosine function? Doesn't matter, and we don't have to decide until we find the C value. A, B, and D are exactly the same for both sine and cosine. C is the one that tells us, are we writing a sine function or are we writing a cosine function? Because sine and cosine are the same graphs, they're just shifts of one another. So that C value gives us which function we're writing. So we'll start off with A. A, remember, is the maximum minus the minimum all over 2. We could try and find that information from the graph, but it'll be a lot easier to find that information in the table. The maximum temperature was January at 28, and the minimum is in July at 15. In case some of you are scratching your heads, how is the maximum temperature in January? That sure doesn't happen in Minnesota. This is south of the equator, where their winters and summers are backwards from us. We'll take that 28 minus 15 and divide it by 2 to give us a value of 6.5. To find B, we need to find our period. How long does it take for it to go from its maximum back to its maximum? From January to January is 12 months. So we have B equals 2 pi divided by the period, in this case 12 months. We get pi over 6 for our B value. Skipping C for now because we still haven't decided if we're writing a sine or a cosine function. D is very similar to A. We're going to take that maximum plus the minimum divided by 2. This time we'll have 28 plus 15 all over 2, which gives us a shift in our principal axis of 21.5. We can see that shift in our graph if we kind of sketch in that principal axis just above that 20. Sine, remember, starts at the 0, and cosine starts at its maximum. We're starting at our maximum in January, so it would be pretty straightforward. We would just put this information into a sine function, and we wouldn't have a C value. But to practice finding that C value from the graph, we're going to write a sine function instead. When we look through these values, October is exactly that 21.5, that principal axis. That's our 0. That's where the sine function starts. So that gives us our C value. C was a shift of 10 months. Now we can put all of that information together into our sine function. Capital T is for temperature. That was the output of our function. The input was time in months. A was 6.5 times the sine. Now we need to use brackets. That B is factored out. We can distribute it back in, but when you're looking at a graph and finding that horizontal shift, you have to have that B value factored out because B affects the shift as well. Remember, when we were given the equation with B multiplied in, we would set all of bx minus c equal to 0 to find our shift. B is pi over 6 times x minus that c value of 10 plus that principal axis of 21.5. You can leave your equation in this form, or you can distribute that B value if you choose. 6.5 times the sine of pi over 6x minus 10 over 6 would simplify to 5 pi over 3 plus that 21.5. Tides are cyclical as well. So we have high tide and low tide, and they come around again at about the same time each day. It's not exact, but we'll figure out how to kind of take these averages and model it anyway. So here we've got high tide and low tide on 2 different days. We plotted those on the graph, and we're just assuming high tide corresponds to 1 and low tide corresponds to -1. That makes our job a little bit easier, and we just put it right on the x-axis, which makes our job even easier. So A is 1 and D is 0. We have no vertical shift, and our amplitude is 1. Jotting down those A and D values. Amplitude was 1. Principal axis is on the x-axis based on the way we graphed it, so we have a D value of 0. In order to find B, we need to know the period of the function. Notice, however, this doesn't exactly have a consistent period. From low tide back to low tide, it took 12 hours and 27 minutes, but the next time it only took 12 hours and 17 minutes, and then it took another 12 hours and 27 minutes. So we're going to average the periods from low tide to low tide. We get 27 minutes. I'm ignoring the 12 hours because that'll be part of it, plus 17 minutes plus 27 minutes, all over 3, rounds to approximately 24 minutes. We're going to make our lives a little bit easier than using that decimal. So the period is 12 hours and 24 minutes approximately. But we have 2 different units. We have 12 hours and we have 24 minutes. So we'll convert our 24 minutes to hours by dividing by 60. So the period of our function is about 12.4 hours. Using all of that to find B, remember B is 2 pi divided by the period. We'll just get a decimal approximation on this one because we don't mix fractions and decimals. And I got about 0.507 for our B value. Last, we need to find that C value, that horizontal shift, and we need to decide, are we writing a sine or a cosine function? We'll do cosine this time, as it will be a little bit easier to find than where the graph crosses the x-axis. To do that, you would take the high tide plus the low tide and divide by 2. You'd find the average, and you can see right here they're pointing that out with x. You'd take the average between the two, and that would be your C. But we can just look right at that chart, find a high tide, cosine starts at its maximum, and that's our C value. Day 1, the first high tide, occurred at 1:18 p.m. We'll have to convert that to military time. We'll need the hours after midnight to get our C value. So 1:18 is 13 hours and 18 minutes. Converting that 18 minutes to hours so we can get all of our time in the same units. Again, we'll take that 18 and divide by 60. And I have 13.3 hours past midnight that our high tide or our maximum occurs. Putting that together for our cosine function, we had an amplitude of 1. 1 times cosine is still our cosine function. Our B value, 0.507, times x minus that C value of 13.3. And again, that D value was 0. We decided to graph this right on the x-axis. You can leave your function like that, or you can distribute that b value if you choose. 0.507 times x minus 6.743. That's how we take a look at real life information and put it into an equation of a graph. Please make sure you let me know what was most challenging so we can start our class time with answering your questions.